Example 3, we want to find a minimum area. A rectangular page is to contain 24 square inches of print. The margins at the top and bottom of the page are to be 1.5 inches, and the margins on the left and right are to be 1 inch. So what should the dimensions of the page be so that the least amount of paper is used? Okay, so first off, let's go ahead and draw a diagram of our paper here. And we're going to have a section of print in here. Okay, so all this stuff has print on it. And then we know something about our margins here. So the left and the right margins are going to be 1 each. And then the top and bottom margins are going to be 1.5 each. And so we're just going to call this value x, and we'll call this value y. No particular reason, we just did. So let's go ahead and come up with our primary equation here. And we're trying to minimize our area of our paper. So the area of the paper is actually going to be y plus 2 times x plus 3. Okay, and we want to be able to minimize this area. So we're going to need a secondary equation, and so we can write y in terms of x. And so to do this, we also know that we want 24 square inches of print. And to get that, we know that x times y has to equal our 24 square inches of print. And so we can let y equal 24 over x, and we're going to substitute this guy right back in here to our primary equation. So we know area equals 24 over x plus 2 times x plus 3. And this is the guy we want to minimize. And to do that, let's go ahead and FOIL this guy. So you're going to get 24 plus 72 over x plus 2x plus 6. And now we can simplify this here. So we have 30 plus 72x to the negative 1, because that's going to be easier to derive, and then plus 2x. Alright, so this is the guy you want to minimize. So what that means is you want to find a prime. So the derivative of 30 is nothing. Derivative of 72x to the negative 1 is negative 72x to the negative 2. And derivative of 2x is simply 2. So now we want to let this guy equal 0, because we want to find our critical numbers. And this was negative 72 over x squared plus 2. So minus 2. Okay, and there's a little trick in solving this where we can just switch these guys. So x squared equals negative 72 over negative 2. And so x squared equals 36. And so x is going to equal plus or minus 6, but negative 6 is not going to be in our domain. And so x equals 6 is our critical number that we're going to have to try. So let's talk briefly about a feasible domain. Most time it's pretty easy just to think that at 6 we're going to get our critical number. And if we think about our feasible domain, right, we could let all of the print be as wide as possible. So y could go up to pretty much anything, and x could go down to 0. So our feasible domain really is going to be infinity here. So really, we're just going to test on the left of 6. So 6 really can't go below 0. Okay, so we're going to test somewhere in here. And then the maximum, okay, would be pretty much anything, because y could go down to 0 as well. So in this case, we'll just get this. So if we tested something like 3, let's just find f prime of 3. And if we plug 3 in here, we would get 3 squared is 9. Negative 72 over 9 is bigger than 2. The absolute value is bigger than 2, so this would be negative here. And we could try like f prime of 7. And now when you square 7, you get 49. Negative 72 over 49 plus 2 actually is a positive number. So if we go from decreasing to an increasing at 6, this would become a minimum. And the minimum would happen here at 6 comma. Well, we're just going to plug this into our x value, so y equals 24 over 6, which equals 4. So we know that this is going to be minimum when y equals 4 and x equals 6. So if we look at this, the entire dimensions of the page are going to be 4 plus 2, which is 6, by 6 plus 3, which is 9. So here are your dimensions.